Okay, we're being asked to estimate 4 inverse trig function values. The answers don't have to be fabulous, but they should be quick and decent, and that's all we want. So the first one was inverse sine of minus 0.87. Remember how sine works. You plug in a t value, a distance around the circle, and the answer is a y value. Inverse sine works the other way. We're plugging in a y value, and the answer we want has to be a distance around the unit circle, usually the closest point. So I'm just going to draw the unit circle. Hope I get into something that's not horrible. I'm supposed to draw the line y equals minus 0.87. Well, minus a half is there, minus 3/4 is there. We're just about to here. So I'm going to just draw something that goes like this. And we want to say, how far is it to that point? Well, that's the closest distance. I just have to try to figure this out. We know that halfway is about 0.8. This is about 1.6. This is about 1.2. I'm thinking 1 or 1.1. I'm just going to say -1 and live with it, which is about right. So that's our first one. We just say what goes in, what comes out, draw the picture, find the distance to the closest point. So that's the first one. The second one I think is very similar. It's just for inverse cosine. So we want, in this case, to estimate the inverse cosine of minus 0.87. Now remember how cosine works. With cosine, you plug in a distance in the answer as an x-coordinate. Inverse cosine, then, you're plugging in an x-coordinate, and your overall answer is a distance around the unit circle. Here we go again. We're drawing a unit circle. Doesn't have to be fabulous. What I want to do, I want to draw the line x equals minus 0.87. Well, x equals minus 0.5 is about there. Minus 3/4 is about there. Minus 0.87 almost splits the difference, so it's going to be like there, right? So it's either to this point or to this point. Now notice, by the way, that along the circle, those are both the same. So a long time ago, they decided if there's two equal distances, always pick the closest one. So I want this point right here. Now what do I need here? I know that that's 1.6. That's 3.2. I get to about there. That's 2.4. That's about 2.8. This is about in the middle of that. I'm going to say about 2.6. It doesn't have to be fabulous. I think that's reasonably close. And that's all we have to do, right? We draw the line that we're supposed to, and we ask what distance does it take to get to that point. So that's an inverse sine example, an inverse cosine example. Now we're going to do an inverse tangent example. On this one, they changed up the number a little bit on us, and they gave us inverse tangent of minus 8.7 like that. Now remember how tangent works. With tangent, you plug in a distance, the answer's a slope. So with inverse tangent, we're plugging in a slope, and the answer, the overall answer, is a distance. Again, we're going to draw the unit circle. And we have to ask ourselves, if I draw a line through the origin with slope negative 8.7, what does it look like? Well, it's really steep, and it goes down very quickly, and it's going down. So I need to just draw something that looks like this. Yes, hits here, and hits here. And we want to know what distance does it take to get to the closest of those 2 points? Well, the closer of those 2 points is the one down here. So what I want to do is just estimate that distance. Now what's that distance? Again, halfway is negative 1.8. I'm sorry, negative 0.8. Another half is about negative 1.2. This looks like maybe negative 1.4-ish. So that's what I'm going to write. Remembering that going all the way down to here is about negative 1.6. Going halfway is about negative 0.8. Halfway between there is negative 1.2. This actually might be more like negative 1.5. I don't care. What I want is that I get roughly the right answer. I get the size of the answer well, and we did the problem easily. All right, last one. Now the last one people tend to view as a tricky problem, but you should know that in trig, this situation happens a lot. In real life, it happens a lot, so we're stuck with it. I now want to estimate my last inverse trig value. I want the inverse cosine of negative 8.7. Remember how cosine works. You plug in a distance, and the answer is an x-coordinate. So with inverse cosine, you're plugging in an x-coordinate. Remember, that's an x-coordinate on the unit circle. And the answer is going to be a distance. So we draw the unit circle, right? We draw the line x equals minus 8.7, which is way over here somewhere. And remember, what we're being asked is, what distance would you have to go around the circle until you get to a point that is both on this circle and on this line? Well, no such distance exists. You can go around the circle forever and never hit that line. This is not possible, and what we're going to say then is that the function is undefined. At that point, at x equals minus 0.87. And like I say, because of the fact that cosine only goes between minus 1 and 1, and sine only goes between minus 1 and 1, this situation happens an awful lot. And so with trig, you need to get used to the fact that very often you're going to get equations that have no solutions, and you're going to get functions that are undefined at certain points.